Okay. Okay, so today we have a full plate. Okay, so I mean, I think so. Some of you are feeling like I'm kind of shoving a lot down your throat. That's partly intentional. Okay, so the idea is we want to give a very nice smorgasbord of tools that are of demand right now in industry, right? So and given the background of everyone, there's quite a big variance. I'm just kind of doing this tutorial style and essentially getting you hopefully brave to do stuff on your own. And if you get anything out of the course, you should be, you should be able to do things like this, um, maybe faster than you are right now able to do. But more importantly, be able to read the documents um, and yeah, have enough foundations to be able to do things on your own. Right? That's the main idea. And in fact, for the second course, your project is the proof that you can do this, right? So it's kind of portfolio driven in that sense. So you can show yourself or your potential employer what you're capable of in your project. Yeah, so you will see. Today we'll kind of go through SQL on actual data sets that we will be using in the SQL. And then next week we will basically do a crash course through machine learning, both supervised and unsupervised. So, but after that, we will be in a place where we can start playing around with more specialized problems, right? Say text or maybe image or whatever. Okay. So let's go to go here, and I figured out what was wrong with my cell yesterday. And I was clicking with the 1000 bytes and it wasn't working. It was just that I turned off the display of the results. So you can go to a cell and actually choose whether you want to display the output or not. And I had it turned off. That's why it wasn't showing anything. So so I fixed those bugs, and then so let's now maybe grab it from here. So I guess about half of you have turned in your assignments, and of those half, about 2/3 have gotten it correct in the first time. So there is no penalty for resubmitting. It's just so but I manually check your solutions and Tilo as well, and so okay. So this is our main notebook for today. So this is a standard example from our package. It's this diamonds data set that a lot of people look at. So we're going to just focus on the extract, transform, load, and exploratory data analysis, so ETL and EDA part of this machine learning pipeline workflow. So, and I kind of want you guys to think in this pipeline sense, because this is what will be useful when you're doing quick consulting or proof of concept things in the field. Okay, so the question is, why are we using data frames as opposed to RDDs or data sets or whatever else? Well, the main reason is because of this explicit announcement in Spark's MLlib machine learning library. So you can kind of quickly look at this. The announcement basically says it's primarily a data frame based application programmer interface, right? So this is essentially why. Okay. Right, and then take a tour here. I mean, there's quite a lot of stuff just out of the box. So we will mostly be doing things out of the box here. But so there's collaborative filtering, which is essentially the bread and butter of recommender systems, right? So does everyone know what a recommender system is? Okay, so a recommender system is basically some algorithm that recommends some product to some user. Okay? So for example, you say you have Netflix, maybe, or you go shop in Amazon, or you just have Google Mail, or you do Google searches and let Google remember your search history. So all these are instances, in some sense, of recommender systems. So the algorithm learns what you like, what you maybe don't like, and it also maybe studies the behavior of other users, your own history, and so on, and it'll sort of give recommendations for you. So in Amazon, if you go and buy a book, for example, it'll say, oh, people who bought this book also bought these other books, right? That's a very naive recommender system. So we will study things like that after some linear algebra under our belt next week. So yeah, what else? Classification and regression is what we're going to be seeing next here. So pipelines essentially allow you to do all the ETL, EDA, setting up the machine learning task, the hyperparameter tuning, which is basically, there will be hyperparameters in your model that you need to tune carefully for your particular data set. And you also have to make sure that you don't overfit your data set. So this is called cross-validation. So we will see these concepts at a higher level more concretely soon. So all these things are taken care of in this sort of pipeline concept. Okay, so Spark uses this. It's completely scalable, and the other nice thing is it's productionizable. That means you can, the engineers, data engineers, and even like guys holding the really hot pipes like the DevOps and layers and so on. So these guys, the engineers, can really take, maybe some innovative algorithms you've strung up together using this pipeline fashion. They can easily take the pipeline and productionize it, which means they can just scale up your algorithms in, say, Google or Amazon or your own private cloud if you're a big government or whatever secret agency, and then they can essentially start streaming in data from, say, users in the recommender system context and serving predictions back to them, serving recommendations, or in the case of regression, it will be predictions or whatever back to them at scale. So, it can be millions or whatever. That's the main reason you want to use pipelines. Okay. So here we will be using decision tree for this particular data set. So again, a decision tree is a specific kind of machine learning algorithm. It's mostly comes from these guys at Stanford, I believe. So it's a very simple idea where you would take your features or your descriptors in the statistics lingo, and you're interested in predicting something usually called an outcome, and the way you do it is you basically take your X variables, the things you're using to predict, and then put them in some domain, and then start chopping them into sort of boxes or hypercubes or whatever. And there are rules of how to chop and what to minimize and all sorts of things, but that depends on the problem itself. And the idea is that these partitioned leaves of this tree. This is the decision tree. It's called a decision tree because at each node it decides whether to, partition the data by being greater than some value or less than some value, for example. So we will see more of this, and this is an example of a non-linear classifier because you will see, because it can kind of fit to strange shapes in the data. Okay, so we'll see this more concretely. And it's in the same sort of nonlinear class as the deep learning algorithms. In that they can fit very complex patterns. And deep learning algorithms can fit a lot more complex patterns than decision trees. Okay, so here what we're going to do is just 2 steps of our full pipeline. So the full pipeline is something like this. So we have we will load data as a data frame, and then we will try to understand the data. Okay, so mostly compute some statistics, create visualizations, and so on. And later on, we will do more standard machine learning tasks like holding out and validating and evaluating and so on. Okay, so to load data, what do you want to do? So in this case, this data should be directly there. It's in Databricks datasets in this DBFS path in our datasets. So this should just evaluate, right? So, okay, and of course, this is a very small data set, but it's good enough to understand. And the exact code will scale to very large data. So now I'm simply using the text file method and taking the first 2 lines and noticing that in the first line, the column entry for the first column is empty, and I have other names like carrot, cut, and so on. And okay, so now I'm going to directly use this method to read CSV files. So I'm using SQL context. So we will kind of go between using SQL context and Spark session just to get you guys comfortable a little bit with not only working with Spark 2.0 plus versions, but also be able to work with Spark 1.x versions, because quite a lot of code in industry is in the 1 world. Okay, so you kind of want to, and SQL context is common to both. So all I'm doing is I'm just reading in this format, so CSV format, and I'm saying yes, there's a header, and I'm saying please infer the schema automatically, and then the file to load is just in this diamonds file path string. Okay. So the default delimiter of this comma separated values file or CSV file is comma, but we will see in the next example we'll change that to a tab character there. Okay, so then I can ask it to print the schema that it inferred as it loaded the CSV file, and this is what we have. So it assigned the name _C0 because it didn't have a column name in the first thing. But for others, it just used the first line as its column names. And it's pretty good at guessing. It says, well, this is an integer, this is a double, and string, and so on. And nullable is true as it can have null values. Okay, so far, most of this looks good. The only place we will mess around with this is the price is actually inferred as integer because the actual values are integer according to Scala. Remember, Scala needs a .0 to see it as a double. So we will cast it as a double. And we want to cast it as a double because we're interested in predicting the price of the diamond based on all of these features. So, and we want the y variable that we're trying to predict to be a double for regression downstream or decision trees, I think. Okay, so let's just count. So this is the action. This is when things are really happening. So we have 53,940 rows. And this is a standard way to do this. I haven't dropped you guys down into Spark Shell yet. I don't know. Maybe we should do that. How many of you guys have gone and downloaded Apache Spark binaries and dumped it into your machine and tried Spark Shell? One. Okay, so we will do it later. Because I definitely want you guys to get comfortable with that, right? But actually, how many of you have Windows laptops, Windows operating systems? Okay, how many of you have Mac? Almost everyone. Okay, and then Ubuntu or SUSE or Linux. Okay, all right. So I suggest that you guys do this to be prepared for some random walks later. So go to Docker. So you want to install Docker. Okay. Yeah. So how to install and use Docker on? Okay, this is for my operating system, but you can just go to docs.docker.com. Yeah, just go here and try and follow the instructions. So Docker is kind of a lightweight replacement sort of for virtual machines. So if you install Docker, then it'll use your operating system, but then add the minimal things you need to be able to put in any other operating system on top of yours. So I've built some Docker files for the course, and they're compressed around 6 gigabytes. So eventually, if you install Docker, then we can all be on the same environment and not worry about a lot of details, especially the guys on Windows. Of course, you can do all of this on Windows as well, except I won't know all the details on environment variables and things like this. Okay, so yeah, just do that. Okay, so let me go back here. So the point here is that if you're in Spark Shell, you can use this .show command, because Spark Shell is just a plain bash shell, and it runs on bash shell, and it's a REPL for Spark, so it's interactive. REPL is what? REPL. Something.
Read, evaluate, print loop.
Yeah, read, evaluate, print loop. Yeah, apparently it's from Scheme. It's a dialect of Lisp. Okay, so it just allows you to interact. Okay, and for data scientists, you want REPL, and Spark Shell gives you kind of the low-level REPL because it's all pure text, and often you will kind of need to be able to do that. But of course, when you're sort of working as a data scientist, notebooks are great because there's a lot more than just plain text REPLing you want to do, right? So, okay, so this just shows me the top 10 rows, and there is caret, cut, color, clarity, depth, table, price, and I think some dimensions of the diamond, just the widest. So as you can see, cut, color, and clarity are discrete, okay, categorical variables, and the others are continuous. Okay, so in real world problems, you will have a mixture of both discrete and continuous variables. Okay, so here I'm simply selecting some of the columns, and what I'm doing here that's slightly different from yesterday is I'm casting the price. Remember, it read in automatically as an integer. I'm casting it as a double type. So for that, I imported this SQL type, double type. And then now my price will be a double, and then I'm just calling it as price. So I'm just keeping the same name. Okay, so now let's just cache this diamonds data frame because this is what I really want. And now you'll notice that price is a double. That's nullable. Okay, so just see the top 10 again. And now you can see price has point zeros automatically added. Okay, so now let's display this. This is a Databricks command. Okay, so display is something you get for the money, and then you get a professional version of Databricks. Zeppelin has its own display-like stuff. Jupyter has its own as well. So this is not something that will work in Spark Shell. So this is quite nice because you're now viewing a table view. So that's what this is, but you can do other things. Okay, so there's a lot of different kinds of plots you can play with. We will do some systematically below. You can also download. So you can do download preview. Preview is, so usually it'll only do the first 1,000, and download full results will let you download up to, I think it's up to 1 million in the free version. I don't know, we'll have to see. Okay, so you can understand the data by visualizing, and this is the mix of categorical and continuous features. Right? So let's go here. Okay, so this is just the Databricks guide on visualizations. And you can, of course, mix visualizations from different languages because you have each language's interpreter running, and you start doing % Python or whatever, %R in the same Scala notebook, or you could come to Scala from somewhere else. So here are some simple examples for Python visualizations in R. So R has a lot of nice things like ggplot. So you can just, and I think toward the end of this class, I will show you guys how to babble between languages once you've created a data frame in a very simple way. So we'll just write to some file and then read that file from another language. Okay, so this is ggplot stuff, and I like this stuff in Scala, so you can create D3. I've been playing with. So D3 is what? Document-driven data or something? Sorry. D3 is a visualization thing for that's really good. Right? Can't remember all the acronyms. Yeah, data-driven documents, right? So this is very, very powerful. And in fact, if you want to do a nice presentation or maybe even sell a product, it's really good because you can ask your users to interact with what you're creating and things like this. So you don't have to be an expert in that to do some basic stuff. Okay, so here all I'm just doing is just selecting a column, so this is the same stuff. So I'm just showing 10 of them. Now you see that they're repeated. So maybe I'm interested in finding out the support set. What are the discrete values this will take? So now we can use this distinct method. Okay, so you select the cut and distinct, and so this is just a recall of some of the stuff we saw yesterday. So now I know that I have, premium, ideal, good, fair, and very good. These are the descriptors for the cut of the diamond. Okay, so just 5 kinds of cut, and you can do the same thing for color. So I think it's pretty obvious, right? I just select the color and do a dot distinct. So I'm just getting these colors. Same with clarity. So this is something you may want to do before you sort of, especially with discrete data, you want to know how many finite values there are, and because often later on you may want to make a call between, even if something looks continuous, and if you find out how many distinct values it has, it may just be, say, a couple hundred, then you may want to exploit that information in even decision trees or machine learning and things like this. And the machine learning pipeline actually allows you to automatically play with different discretizations and coarsenings of possibly continuous values. This is a good idea. Same thing, right? When you're trying to look at behavior of people, whatever, right? Like there will be like a big spike, and if your time at which you're measuring something is up to 15 minutes, then you will start noticing, maybe people are going to lunch, in just between 12:15 or 12:15 to 12:30, and so although time is continuous, you may gain quite a lot by discretizing things. Okay, so here I just want you to start playing with the stuff. So I just use the display command on the select cut, and what I'm doing here is if you go to plot options, you can see all the stuff I've chosen. I've chosen a display to be bar chart. There's others you can choose as well. And I've asked it to be grouped. And then series grouping is cut because I want the series to, group by cut. And then I'm taking the ID values. ID values are just the indices for the first, for each row. And aggregation, I'm just basically doing count. So this is simply a visualization of SQL statement, right? Okay, I don't know what, I need to go smaller. Okay, so I can just apply, and that's what this is. So you can play around with different options. And in fact, yeah, try and do the same for clarity. So this takes a little bit of getting used to. So in this case, you see, I already pre-selected only cut and ID, so I can't do clarity. So I have to actually just do the whole thing again. This is just to get you doing something with your fingers. So so this is just color, and now it just gives me the table by default. So I have to go. Maybe let's try this. Try bar chart, see what it does. Let me just go here. So I need the series grouping to be color and values to be ID, and this will give me a bar chart. Okay, so but I'm summing now. I'm summing the things I probably want to count, and it doesn't matter. So say pie chart. That looks really, yeah. For pie chart, you probably want to be, yeah. Okay, just play around. So now, what we would typically be doing is, usually these things that you play with maybe only say 20 or maybe 40 variables. So you would just load the whole thing like this, and you can go to this view, which is the table view. This is where you need to be to hit the downloads, if you like. Let's say I download full results. It'll say re-execute and download full results. All right. So I've never done this in the community edition. So there you go. So it brought me some export.csv file by default. So that works. So then what I guess I'll just try and do this. I hit this thing and plot options. Now you can do other things, right? I can say, sorry. Now I can say, maybe I'll grab clarity here and do both color and clarity. It gives me these ordered pair things. Maybe try stacked on this. That's pretty stupid. So, so I can do this for clarity. Grouped. So you can stop playing with various things. So you can choose this to be different. So you can say I'm interested in, say, the sum of be all the carrots. Yeah. So this kind of stuff is quite good too, if you want to look at the details. Okay, so yeah, so you can play around with this. Zeppelin has a bunch of stuff as well, and actually, if you guys are really hardcore about this, are there anyone in interactive visualization group here? Okay, so I don't know, I saw some video a few months ago from Netflix guys, so they have this Zeppelin interface in one of the Spark subnets that's like a matplotlib for Apache Spark via Zeppelin notebook. And that does some amazing stuff because it lets you see a lot more of the data because, yeah, you may want to see much more than, 10,000. Okay, so you can play around with this. Okay, now I'm just looking at the caret, and this one's, yeah, just a density plot, so you can follow instructions about to see how I plotted it. So when you look at this distribution, what you're now seeing is I have this sort of skewed thing, and generally when there are sort of values toward an extreme and it's not normal looking, then usually a standard regression is not the best thing to do. Okay, because a standard regression assumes that there is a linear relationship and that the noise, exactly where the data is from your predicted expected prediction is a Gaussian noise or a normal noise, right? And but decision trees will be probably better for this example. Okay, so the other thing you will want to do is, if you have a very, very large data set, then you can use this method called take sample. So I think, so take sample, if you look in the docs for take sample, you can specify a fraction of the full data set you want to take. And then usually you want to take a small fraction and count it before you visualize it. So, and for large problems, you will already be sort of taking sneak previews of the data by taking samples with different random number seeds, pseudo-random seeds. So you get different randomly sliced samples of a large data, and you can use this display thing to play around. Okay. Does everyone know what a pseudo-random number generator is? You've seen a PRNG, okay. You haven't, I mean, it's basically like pseudo is like false, right? So random number. So it's like, it's actually something that von Neumann came up with in Los Alamos to go beyond the mathematics that he could do, right? People like Ulam were there, right? So they were trying to find the detonator for the US bomb, right? The atom bomb. So it's a branching process, and they just didn't know how the behavior will be. And so then they said, okay, let's use this very simple argument. It's called the middle square method. That was the first pseudo-random number generator von Neumann did. And the idea was to somehow, spread points uniformly at random in the unit interval by simply doing modular arithmetic, right? So modular arithmetic is clock arithmetic. So you have 0, 1, 2, 3 to really, really big integer. And then you basically do addition, subtraction, multiplication, division around the clock. And you hop around like mad. And this sort of pattern of hopping, if I didn't tell you, this is like deterministic. And you're supposed to guess whether it's deterministic or not, because you pretend that there is this other thing that the oracle gives me is magical and completely random. And if you cannot decide, that it's deterministic or random, then it's called pseudo-random. If it passes certain tests, then it's pseudo-random up to these tests. Right? That's the idea. And often, why is uniform, samples from the uniform density? So when you're jumping around in the clock, well, integers basically, then what you do to sort of project that to the unit interval 0, 1 is you just do a rational division, right? So you divide by the biggest, the modular, the largest number here, right? So for this clock, it's 12, right? The largest integer. So you will just get numbers between 0 over 12 and 12 over 12, right? So these rational numbers. Of course, 12 is several billions, it's going to be quite dense on the unit interval. So it'll look like it's like samples from uniform density. And then the fundamental theorem of simulation basically is, again, von Neumann's rejection sampler. This guy did quite a lot. In those days, these guys were electrical engineers and computer scientists and logicians, mathematicians, and detonation, inventors for atom bombs. It's a bit unusual. So what you basically do in fundamental theorem of simulation is, if you have a random variable in one dimension, right, like say exponential or something, then there is the cumulative distribution function, right? Okay, which is basically the probability that the random variable takes a value less than some given number, right? It's called the CDF, and it kind of, starts at 0 at infinity because there is nothing below negative infinity that has any probability, so it sort of hugs 0, and then it kind of goes up, and depending on whether it's a discrete random variable or continuous, it can have jumps and so on, but it'll always be non-decreasing. That means it'll be constant or increase, right? And then eventually it'll asymptote at 1. So if you go to positive infinity, it'll be touching 1 all the way, right? Because the probability that something you measure by this random variable is less than positive infinity is 1, because you, by definition, are saying everything goes into the real line. Okay, so that's the cumulative distribution function, and the fundamental theorem of simulation is simply the inverse of the cumulative distribution function, right? Because the cumulative distribution function takes values between 0 and 1, and it's non-decreasing, I can define what's called the inverse image, which means if I'm given a point in the unit interval, which is now the range of the CDF, then I can just kind of go back, right? Invert it and go back to the domain. That's the fundamental theorem of simulation. So that means you can now transform samples from the uniform 0, 1, the standard uniform density, to any other random variable if you know how to invert the CDF, right? Okay. All right, that's basically simulation in like 6 minutes, but that's kind of enough. Okay, so what's happening here when I haven't done the example yet. We'll do it later in a big data set. When you do this, you basically have a seed of the random number generator. So remember, the seed is basically the initial value, because all this guy is doing is just jumping around in some modular, in some set of integers. So it's controlled, because it's deterministic, it's completely controlled by the initial condition you give it, and that's called the seed. So this way you can deterministically produce simulations, right? So you can change the seed and get completely another one. So by controlling the seed, and if you're using this to produce random subsamples, you can get deterministically different random subsamples, right? Because you may not be able to visualize more than 1 million, even with this Netflix gadget, right? That you can throw on top here. So then you will want to do clever subsamples of about, say, 10,000 or 1 million, right? And this is all you have for visual insights into making your algorithm better. Okay, so this is just a bit more stuff. So you can select cut and carrot and see them. How does the caret of the diamond depend on the cut? And I guess obviously the cut is ideal. That's more caret. Okay, so this is very, very useful, especially for under maybe 6 dimensions, between 3 and 8 even, because these are called scatter diagrams, right? So have people seen this scatter plots? Scientists must have seen this. Okay, so scatter plots are pairwise plots. It's kind of interesting how some people have not seen some things, which is good. I think that's the idea. Oh God, I'm lost. So I think if you click that, there is that scatter button, and all I did is just push that, and this popped out basically. And what you're seeing is this is a pairwise scatter plot. So you're seeing, for every pair of variables, I'm simply plotting, the pairs as dots. Right? So this is now Z. So the Y value is Z for all these top plots. Okay, and so of course the diagonals of this is Z versus Z, right? Which is going to be just lying on the diagonal, right? But the density of the points on the diagonal will be different. So this is a standard way to show Z against itself, which is actually as a density, and so on. So this would be price versus price. And so if you look at this closely, you start seeing these nice linear patterns, right? So Y versus Z and X versus Y, there's a lot of linear correlation, probably because I guess when X dimension increases, Y also increases, because these are kind of globular objects. I don't know. Okay. The same with price. So yeah. So price seems to be in two huge clusters. Okay, so this is sort of something you would do to get some insights. And for diamond data, it's a bit difficult because it's really very little physics. It's more about, I guess, marketing these diamonds. I don't know, or maybe how they're mined. Okay, so here is another way to do this. So this is just visual, but you may want to be interrogating your data logically, using this relational algebra of SQL. So here we have, HiveQL, which is a richer query language, and it supports various, binary operators, and it also has some other like operators. You'll see what I mean by that, just some kind of partial string matching, fuzzy string matching stuff. Okay, so let's not learn everything about SQL, but just get some simple examples. So here I'm just simply saying, this way of writing things, where I'm simply saying select and some columns and apply some transformation, like filter, right? So this is the way of doing it with data frames, and this is effectively what I would like you to learn to do, because this is what we will carry through. But it's also very important to, if you're comfortable in SQL, to be able to just do SQL expressions. So there's no problems there. So you can do this. I'm just checking that the color is that I've filtered by D, and yeah, this is just checking that it's really distinct. It should be. Here I have my table. So I want to first know what are my tables in memory. Okay, so this is probably from my academic shard, so there's lots of tables lying around. So this is what's there in the community edition, right? I actually have some SPLC complete table. This is from some Twitter analysis I did. So what I want to first do is to create a view like we did yesterday. So I just take my data frame and simply do create or replace temp view. So I create a temporary view of my data frame so I can get it as a table. So now if I do SQL context.tables.show, I see that diamonds has been is now available as a temporary view. So now I can do SQL. So I'm back to %SQL land. So this is a pure SQL cell. I'm just doing select caret color price from the diamonds table where color is D. So this is exactly like the data frame based dot select and dot filter, right? This is exactly equivalent to the previous. Okay, so alternately you could just write the SQL statement in Scala to create this. This is another way, right? So you do SQL context.SQL and just put the string in. So now we don't need to jump into SQL in a cell, right? We can just do this. But of course, you still need to have created the view, the temporary view of diamonds. Okay. So yeah, so here, I don't know, there's all this notation, like some people use these SQL strings in uppercase. Is there like some, yeah, it works either way. So in my class, you can do whatever, but I think some people are religious about what should be uppercase and stuff. So do whatever your boss or your coworkers want you to do. Okay. So this is just showing you some other standard SQL stuff. Okay, so you can now display this because that comes back as spark.sql is actually only in version 2.x onwards, right? This one will work in older versions of Spark, but this one will only work in 2.x onwards, right? So this guy just creates a data frame for you, and you can just see that. There's nothing wrong with intermixing things, especially if they're simple. Here is just passing that to display and just seeing stuff. So from the diamonds table, where clarity is like, V%. So it's like anything that begins with V basically is now picked up. So this is some, I believe a lot more of SQL expressions are allowed in Spark 2.x. And then the distinction between Hive QL and Spark SQL that was there, I think, has gone away now. So anyway, there may be some multi-nested SQL statements that won't work. I don't know. Okay. So here is, we're doing a little more interesting things, finding things with price more than whatever. So this is classic business intelligence, business logic, whatever, database stuff. Okay, so here I'm just playing the same thing. Give me price. Okay, and now I'm just naming carrot as carrot, so you can just rename the columns, sort of some SQL stuff. Some of these things we may need down the road, but okay. So we can order the price by descending and see what's the most expensive diamond. Carat is 2.29, clarity is BS2. What's the highest price? Okay. And just printing the schema again. So now I'm just ordering by carat in ascending order, and the price is in descending order. And yeah. Anyway, most of the stuff I think I can play around. This is just the Spark 2.x version. Okay, maybe it's time for coffee. I hope we have coffee outside. So I don't know, like, if do you guys think this fika thing is good?
Yeah. Yeah.
All right.